So hello everyone and welcome to this special webinar on light pollution and its effect and the problems it causes. My name is Julie. I'm the coordinator for the program Discover the Universe. And before we get started with today's talk, I just want to say 2 minutes about this program. This is your first time. Yes, so there we go. This is the talk for today. So Discover the Universe is a program offered by Canadian astronomers. We are actually, it's a program offered by the professional astronomers through this Canadian Astronomical Society and the amateur astronomers through the Royal Astronomical Society of Canada and the equivalent in Quebec with the amateur astronomers in Quebec. So basically, astronomers in Canada, professionals and amateurs are behind this program. And our goal is to give teachers and informal educators the knowledge, the tools, and the confidence they need to teach astronomy. So we have different workshops throughout the year, and we have different webinars as well, such as the one today. So our upcoming activities, we do have an international workshop for teachers. This one is in French only, but I'm mentioning it here because we received money from the International Astronomical Union, and we're pretty happy to offer this workshop for teachers in the whole Francophone world. So this is starting next week. Maybe eventually we'll do it in English as well, but for now it's just in French. We will have a webinar in January, a repeat of what we did last year in January 2015, astronomy news and preview of 2016. The date is not set yet, but you should receive, if you check that you wanted to receive information about our future programs, then you will receive an email telling you about it. And we do have a workshop for teachers. This one is in English as well. It will be in February. So it's a 3-week workshop. So you can let teachers know if they want to become more familiar with astronomy and more confident and have activities they can use in class. So this is our website. You probably know about it, but if you're new or found the recording for this webinar without going through our website, you can go there and register to our programs. Everything is free, and it's offered in both languages. So except for the International Workshop for Teachers, which is offered only in French, everything else is offered in English and French. So I will come back to station. We have 2 guest speakers. They are both in Calgary right now. Actually, they are at the Ruthney Astrophysical Observatory right now. So we have Roland and Phil in the background, and they can come. Oh, we can hear you now, I think.
Hello.
Hello, yes, we can hear you. So while they bring up their webcam, I just want to mention to people participating live that you can ask questions through the chat. And yeah, we'll see them better in a minute. Hold on, the webcam is kind of funny when my face isn't there too. So people live, you can ask questions through the chat. And because this is also recorded, if you are watching the recording, of course, you can't type, but you could always email me if you have questions. So I will be in the background in case there's anything happening, but I will leave you with Roland and Phil. And there you go, gentlemen. It's up to you both, and hopefully the camera will readjust. There you go. Now we can see you. So welcome to both of you, and thank you very much for accepting my invitation.
All right. Thank you, everyone, for joining us today. We're at the beautiful Rothney Astrophysical Observatory in the Interpretive Center. My name is Roland Dechesne. I am a member of the Royal Astronomical Society of Canada. I have been a member for over 35 years. My day job is as a geologist, but my real passion is astronomy and the protection of the natural night sky.
So I'm Phil Langill, a longtime U of C person, director of the Rothney Astrophysical Observatory. I don't know about Roland, but this is my first webinar, so I hope I don't blow it.
Rookies. Oh, I'm a rookie too.
Oh, okay, great.
All right, so we're sitting here, the Rothney Astrophysical the Southern Alberta chapter.
I'm sorry, gentlemen. I'm sorry about that. The sound is actually very good when Phil talks, but it gets really bad when Roland talks. I don't know if you could make it better somehow. It's kind of weird. Or try to speak a bit louder, maybe, Roland. Sorry about that, but we kind of miss part of what you're saying. So I just thought I would interrupt. So sorry, I'm hiding again.
Yeah, it looks like we're going to have to get closer.
Yeah, right. Good thing we had our minutes earlier. So the Rothney Astrophysical Observatory is actually the seat of the Southern Alberta chapter of the International Dark Sky Association. So today we're going to run through a lot of topics, probably mostly superficially, unfortunately. My usual way of doing things is to go deep diving into various specific topics, but today we're going to try to do a bit of a survey of the whole field. I suspect there'll be lots of things we're going to have to gloss over of my audio so far. Julie, can you still hear me?
Yes, I can hear you. My microphone was muted. It's not super, unfortunately, so we can hear you. I don't know if everybody else is hearing the same thing as I am. Can you please mention in the chat if the sound is good or it's not so good when Roland is talking? A few people are typing, so we'll just wait to hear the answer. Sorry about that. We're just gonna take a minute trying to fix this because it's it's breaking up. Yeah, so move closer. Maybe what we could do, not that we don't want to see you, Phil, for now, but if you wanted to turn your computer just to Roland at first, and it seems the sound is better that way, so maybe we'll try that. So let's try that, and I will interrupt again if it gets worse. So, okay.
All right, let's do a sound check first before I get too far along.
It seems better for now, so it seems better, so hopefully it will stay like this.
All right. So nighttime lighting. Well, we need it. We need it for visibility and safety. We need to enhance surveillance, and it can be used appropriately to create attractive environments. But there is a downside to lighting at night, and it can cause energy waste. You can create unsafe areas due to glare, etc. And there's a lot of negative environmental impacts, and we're definitely going to be talking about those negative environmental impacts later on here. One thing I should get out of the way right up front is this relationship between crime and lighting. For a lot of people, this is why they put up lighting at night, but what we have seen with a variety of studies is that studies generally find no relationship between lighting and crime, and that we just feel safer when there's lighting. And in fact, I'll go a little further than that. The best designed and executed studies show that artificial lighting shifts daytime crime into the night hours. So it's not really improving the situation at all. And when we ask the criminals, what motivates them to target where they've been doing some thievery, they cite signs of occupancy, difficult entry, so locks, barred windows, and so on, dogs and alarms as the things that are deterrents, and lighting is not listed amongst those deterrents. And I see a question there in the text. We'll probably make it available, but certainly this is going to be available as a YouTube video, which you'll be able to view. I see that question there. So light pollution. I think this is what people imagine when they think of light pollution. This is a photograph of Calgary taken about 25 years ago. And you can see this glow of light above the city. And I think for many people, this is what light pollution is all about. Now, it turns out that we're really looking at only one part of light pollution when we look at a picture like this, and it's sky glow. And that's the light shining upward, brightening the night sky. And this is certainly why astronomers are very motivated to learn about light pollution and to try to control light pollution, is that it's brightening the night sky. But I want to kind of disabuse people of the idea that this is all what light pollution is. In fact, for many people, they don't really care that much about the night sky. Certainly there's a good fraction of the public that do care about seeing a nice dark starry night. But the reality is there are a lot of people who really don't see this as a part of their daily or nightly lives. So we want to redefine or broaden the definition of light pollution a little bit here. I think first and foremost, I think we have to underscore this. Light pollution is waste. Basically, you're using too much light. You're putting it in places where it's not necessary. You're probably using too bright of a light source. So we want to kind of, for most people, we really want to bring this to the attention of the public. Now, there are other aspects of light pollution besides the sky glow. In fact, you see I've put that down at the bottom of the list here because, again, it might only affect a small fraction of the population. But light trespass, where light is shining where it's not wanted, is an important aspect of light pollution. So is visual clutter, where distractions may mask a number of hazards. Glare, and that's light shining out at high angles and it reduces visibility. And then finally, yes, sky glow, light shining upward, which brightens the night sky. So what we're going to do in the next series of slides is just kind of look at each of these in turn. We'll start off with waste. And think about this. Many of you might still have an incandescent bulb on your porch light. So what is the cost of that dusk-to-dawn 100-watt lamp? Well, it'll consume roughly this amount of electricity a year. Roughly, $45, $50 a year to run. Here's a kicker. In many jurisdictions around the country, a good portion of the electricity that is being used to light that light bulb is derived from burning fossil fuels, whether it's coal or natural gas. The typical average is around 390 kilograms a year of carbon dioxide emissions. That's a substantial amount. And to visualize that, try this on for size. That's enough to fill 44,000 8-inch party balloons, 20 centimeter. Yes, we're metric here in Canada, aren't we? So that's a lot of carbon dioxide. Moving on to the light trespass. That's basically light shining from one property onto another, shining into your bedroom windows, for example, or any light that interferes with your enjoyment of your property. Here's visual clutter. It's hard to imagine what you should be focusing on if you're driving in a situation like this. It's difficult to understand whether you have pedestrians in that scene or not and where you're going. And that's one of the bad aspects of unregulated lighting. And then there's glare. We've all experienced this. You're on a country road somewhere, you're driving along, and approaching you is a second vehicle with their lights on as well. And yes, there's twice as much light on the roadway between the two vehicles, but you sure do not see twice as well, right? So glare is characterized by a brighter light source and a relatively darker field of view. Our eyes always adapt to the brightest light, making the surroundings appear darker. I like to think of a 10-to-1 rule that basically minimizes the amount of contrast in the image. Once you've gotten something that's dimmer than that 10-to-1, it gets a little bit more difficult to see that up front very easily. It's not that you can't see things that are dimmer than that, it's just that they are no longer that apparent, that especially in the moving vehicle that you're going to be able to see them. Glare always reduces visibility, and it always reduces security and safety because, of course, many hazards can hide in the dark areas that are not lit. So we're going to go to Dr. Phil here for a classroom demonstration of glare. For any of you who are teachers or do workshops, I first saw this, or a version of this, with Connie Walker at the Globe at Night, and it's a very effective hands-on demonstration.
So we're actually, this is kind of funny, we're in the interpretive center at the Rothney Observatory and we're sitting in the dark. Not that we like being in the dark, but we wanted to have it dark so that this demo would work out. I hope it works. So what Roland was saying is it's funny, you add light because you want to see better, but glare is the addition of light that reduces your ability to see. So I just have here a light bulb on a little lamp, and we're going to pretend that this is a source of light. And when we turn it on, okay, do you see my face? Does everybody see my face nice and clear? We're going to add more light, and it's going to make my face better, right? So here we go. Classic glare, right? We're adding more light. We're thinking this is going to help us to see better. And of course, what we're doing is we're not putting light where it's needed, number one, and it's just a total waste of light. It's not helping us see better, and this bulb is now wasting a lot of energy. But there's a fun, simple, and interesting little fix. So all we need to do is hide the filament of the light. So what Roland is doing is he's putting a very expensive piece of equipment over the bulb. This is a tin can, and he's holding it over the bulb. So now you can see that the light is shining down onto the ground where the light was intended to be in the first place. And it's reducing the glare so you can see better by getting the light out of the people's direct eyeballs. Lots of glare and a little bit of a cover on the light. You reduce the glare. The light is now more functional because we were trying to light down the ground, and now the light's being directed down the ground. Great little demo to demonstrate the concepts of glare. All right. Anything else to add to that, Roland?
Yeah, I'm going to put this tin can down. The tin can was getting very hot. Where you need it, and don't need it. The reality is you can put in a much dimmer bulb into that fixture, so you're using a lot less electricity, and you're getting a much better illumination out of the whole product.
Sorry, Roland, here I am again. Can you turn the computer a little bit more towards you? It seems the microphone is on that side, and it makes a huge difference. There you go. I think it's going to be better for the sound. Thank you.
You want me to repeat what I just said?
That might be a good idea.
Okay. So I was just commenting how hot that can was, and that's because that was a very high wattage incandescent bulb. Probably not the most efficient light source to start out with, since much of the output is in heat. However, by shielding the light to put the light where it was needed, we actually could get away with a much less extreme wattage bulb. And so you can start off by saving electricity and getting better illumination just by directing the light where you need it. All right, moving on. Finally, the bane of the astronomer. That's sky-glow. And this is why, as I mentioned earlier, the astronomers are all up about light pollution. But I just wanted to make sure that everyone understood that light pollution is a much bigger issue than just this. And so this is the brightening of the night sky, and it's caused by scattering of artificial light by air molecules, water droplets, and dust. And it seriously hampers the observations of the night sky by astronomers. And it's symptomatic of other lighting problems. That is, if you have a very high sky glow, very likely you're suffering from one of those previous examples of whether it's overlighting or glare or any of those other aspects of light pollution, light trespass. Probably all of those are occurring at ground level, and you see the symptom up in the sky. All right, so back to Dr. Phil.
Right. Okay. So as Roland says, hope you can hear me well. As Roland says, astronomers are interested in seeing the nighttime sky. I want to also say that it's not just astronomers all the time who are interested in seeing the nighttime sky. I think everybody enjoys the opportunity to see a star-filled sky. Of course, astronomers want to measure the light that comes to us from space, but the average person just wants to sit around a campfire, look up at the nighttime sky, and see all the nice sparkling stars overhead. So sky glow affects everybody. How's my sound?
It's
All right.
it's very good, Phil.
Okay, good. It's because I'm using my teaching voice, I guess. I want to show you an interesting little app. Now, there's lots of ways for people to participate in the monitoring of the nighttime sky at night. There's a great app that I love to use. It was developed by some folks at the University of Berlin, and it's called Loss of the Night. I'm just going to hold up my little cell phone here. Maybe you guys can see the little app. It looks like a little owl. No, you guys can't see that. Forget it. So there's a little owl. It's a loss. It's called the Loss of the Night. The thing that's very cool about this is it's not using the phone on your camera as a source of light measuring. It's getting the person who's using the app to use their own eyeballs to gauge the brightness of the sky. And it's very clever. It asks you questions about, do you wear glasses? Is there clouds out tonight? What's the phase of the moon? In fact, if the moon's full, it'll tell you, don't even try doing this because the moon's full and it's going to mess up our observations. It knows from your cell phone where you are on the earth, what time it is, all that kind of stuff. And so the idea is the app guides you through the nighttime sky. So it knows what stars are overhead. And on your phone comes up the little cell phone app, the typical one where you hold your phone up to the sky and you can see the stars. And it says, if this particular star is overhead right now, can you see it? And so if you're not familiar with the constellations, you're not familiar with the stars, you hold your cell phone up to the sky, and what stars are right in front of your eyes show up on your phone. And there's a little arrow, and it says, no, move your phone this way, no, move your phone this way. And so your phone guides you to the star. And then you go, oh, I see that star. And then you say, yes, I can see it. And then it repeats the process with a slightly dimmer star. And you go around the sky. And so as you go from brighter to fainter stars, at some point you give up and you say, I can't see this star anymore. So at that point, the data's been entered, and it knows based on your response of seeing the skies and the stars that are up there and the dimness of the stars, you've told them how bright the sky is. It works really well. This program is the app is really smart. I haven't had any problems with not showing you the stars that are in your sky at the moment. Very, very simple to do. The data that's collected, it goes to a database that's used by experts to monitor the sky in urban areas, in rural areas, around the world, in fact. So you can participate in an around the world exercise to monitor and gauge the brightness of the nighttime sky. Isn't that strange to think about the brightness of the nighttime sky? One other thing, if you're a real geek, then you might have one of these. These are a sky quality meter. We have a few here at the observatory. This is the handheld model. The app, the Loss of the Sky app, will actually ask you if you're using an SQM rather than doing the eyeball exercise. Just measure the brightness of the sky with the app and give us the number. So it's pretty fast and it works really well. Sky quality meters are really good. Very reliable way for people to measure the brightness of the nighttime sky, a feat that's been accomplished in recent time. All right, I think that's said enough about that. I'll pass it back to Roland.
All right, so that app Dr. Phil was talking about is available for all smartphones, but there's also the Dark Sky Meter app for iPhone products only, and that's because Apple's cameras are all very consistent, and it can be used as a light meter directly. But if you're using an Android device, this app doesn't work for you. And so the Loss of the Night app is probably the preferable one, and it's certainly getting wide use around the planet. And you can go kind of old school. This is one of my favorite programs, and I mean programming not in the software sense, but the campaign to map the brightness of the night sky. And this one, I'm old school with this. I like to print out the paper maps and of the night sky and compare the sky that I can see to the brightness that is associated with that. So the globe at night works year-round. It is happening every month in the kind of the dark of the moon part of the month. And how it works is you get a map. Like I say, I actually drive around with my paper copies of the maps just to compare. And each month there's a different constellation that is the focus constellation. So you do need to be able to find your way around the night sky a little bit. It's not too extreme. And this is a map from a few years ago, so when Mars was sitting in Leo. And in a perfect sky, you get overwhelmed by the number of faint stars. And more likely, for most of us, when we get out into the countryside, we might see a sky like this. And you can see the brightness down below in the lower right-hand corner there, something like 6.5 magnitude. A great sky, if you're just outside of an urban area and you get into your nearby observing site, might look something like this. And fewer of the faint stars are visible, but still the main constellation patterns are visible. If you're in a suburban sky, a good suburban sky would look like this. You're still able to pick out Leo, and at this point I am actually going to draw here. So here is the backwards question mark that marks the sickle of Leo. That's the back of the lion's head. Here's the body out basically through here. I like to think of Leo as sitting as the Sphinx is. So here's the front paw out in front. And there's Denebola, which is literally an Arabic word meaning tail of a lion. So there's our lion in the sky. So now this is what you might see in a good suburban setting. Typically, you see fewer stars, and then you have to kind of look farther afield to kind of figure out what part of the sky you're looking at. So here's a wider field view. This is getting closer to downtown areas. Downtown Calgary looks sometimes like this. It's very poor skies, very disheartening. And then I haven't seen skies as bad as this. And then apparently some places on the planet have this. So what you do then, once you've got all of these comparison charts, is you just figure out which one matches the sky that you're actually looking at and decide how to enter the data. And there is an app that you can use for your smartphone. Quite often I'll just scribble my notes on a piece of paper, where I was, what time it was, how bright the sky was, and then I'll sit down and enter that into the website directly when I'm at home. What can you do? Well, this is 2 nights worth of work on a medium-sized city or a smaller city, Lethbridge, Alberta. And I basically just drove around through that area. In fact, this isn't all the data I collected on those 2 nights. There's a whole stretch off to the north that isn't covered in this map. It shows you can map a pretty good-sized city. Now, this is one person with a vehicle. And I have to say, maybe I'm a little obsessive-compulsive about this, so your results and mileage may vary. But as a classroom exercise, this is about as low-tech as it gets. You can print out the handouts for the constellation, and what I would recommend is the students, and everyone views the sky a little bit differently. The beauty of this map is that it's one observer, me, and so I'm very consistent in how I apply my brightness criteria. But if you're going to do this for a classroom exercise or a club exercise, one thing you should probably do is get 1 or 2 key points on your map where everybody or most people can get to and compare their brightnesses. So you kind of cross-calibrate against each other, and then you can then compensate for individual observers' variations in what they can see, and so on. But anyway, all of this data is collected at the Globe at Night website. This is a screen grab off of their website from a couple of years ago, where they had posted all the data I collected in Lethbridge. Oh, I'm going to just back up here. So what's the value of collecting data like this? Lethbridge was undergoing a retrofit of street lighting at the time, from high pressure sodium to very cool white, bluish white LEDs. And I was actually able to detect the difference in the different streets in the sky glow associated with the bluish LEDs being much more scattered sky glow. I've used similar maps in the Calgary area to talk to aldermen, to talk to city officials, to talk to Alberta Transportation, who was proposing a ring road around the city and had chosen a variety of different lighting for the previous segments of the ring road. And I wanted to talk to them about what they should be trying to put in the next time they do some construction. And so these maps basically can be done very inexpensively. It's just a little bit of labor, but you can actually get a lot of mileage out of them in terms of talking to city officials. So, still on sky glow. I love this quote. We had a youth member a number of years ago who made this observation. Light pollution makes it hard to see the stars that connect the constellations. And it is so true. And it's not just true for humans, though. And it is true for astronomers, though. And let's go for another interlude here from Dr. Phil, the real astronomer in the crowd.
So, this is a fun thing to ponder. What I'm showing you here are the actual images taken by Rob Cardinal with the Baker Nunn telescope, whereby he discovered this asteroid this night. So I'm going to click on the little arrow, comet, pardon me. Do you see it? It's here, it's here. This little dot of light that moves across these 5 images were the first images ever taken of this comet. So it's a very simple technique. You take a picture, wait a couple minutes, take a picture, wait a couple minutes, and then the computer analyzes where all the stars are, and if it sees something that's moving, it flags you, and then you have a look and investigate further. What I want you to think about, though, is the stuff that's between the stars. The stars are standing out there nice and bright. The comet is incrementally stepping across the sky. But if you look between the stars, you don't see blackness. You might think that that's an odd thing. If you look up to the sky and you see the stars, to your eye, between the stars, the sky is black. But the cameras, research-grade cameras, are designed to actually count photons and see photons. So if you just pick a spot, I'm going to click on an arrow, click on the arrow, the little green arrow, and click right here. So just look where that green arrow is, and you see that there's a pixel that's responding to something that's giving it a signal. And it's varying a little bit from frame to frame. What you're actually seeing is photons that are bouncing into the telescope from just above the telescope. So these are not photons from space. If you look at the stars, clicking on a star, those photons are photons from a distant star in space. Between the stars, you would think it'd be nice and dark, nice and black, but it turns out that there is some particulate, a little droplet of moisture, a dust grain. Roland can tell you more about what's up there in the air, but there has to be a photon from some terrestrial source bouncing off the air and going into the telescope. So the little background flickering that you're seeing there is man-made light. If you throw more light up into the sky, what happens is the overall background light level of the sky goes higher and higher and higher, and you can see what's going to happen. Eventually, the background is going to put more light into the telescope than what you see from this little comet that's bouncing across the sky. So if the light pollution had been worse on this particular night, specifically if the light pollution made the average sky brightness bigger than the little bit of light coming into the telescope from this little comet, then this comet would have been undetected. So this is what astronomers are thinking of when they think light pollution. Astronomers are trying to measure very carefully light levels, counting photons, and if the sky itself is throwing light into the telescope, then that's background noise that you have to take care of. And if you want to make discoveries these days, it's all about pushing the limits of your telescope and going fainter and fainter. And yeah, thank goodness that the sky was as dark as it was when Rob made these observations that night.
Very cool. And I point out that that is not Rob Cardinal's only comet that he discovered with the Baker Nunn. He actually has two. And that's just outside a major urban center, Calgary. Well, I'm going to segue here from astronomy by humans to astronomy by birds. Skylo has impacts outside the human realm, and you might know that Canada's small bird population mostly arrives and leaves at night. They migrate at night due to the cooler temperatures, which leads to denser air, less turbulence, and quite important also for these small birds that they avoid their main hawk and crow predators. There is one other aspect that they like about migrating at night, at least for some of them, and that is the possibility of star navigation. Now, this seems a little far-fetched, but it actually has been studied and been proven to be so. Specifically, indigo buntings were found to use star patterns near Polaris, the North Star. They raised batches of these little buntings, a small finch-like bird, in a planetarium, and basically set up two scenarios. One where the sky rotated around Polaris, and a second scenario where they took the projector and rotated the sky around Orion. And that what they found was that the birds' preferential flight patterns in their cages were directed by what star patterns they could recognize in a planetarium. So it turns out for these little guys that there's an area around the pole star, Polaris, that they really key in on. And so this, inside of this circle, these little birds apparently learn these constellations or star patterns, maybe not our constellations, let's say star patterns, while they're in the nest, such that they can later on use those stars to figure out which way north is and which way south is. Now, there is some studies that suggest that even a bright moon will interfere with those birds' stellar navigation, and it's a foregone conclusion then that light pollution can make this problem worse. Here's an image of Western Canada and the Northwest United States here from the DMSP satellite, and we're looking at uplight. Calgary there, very, very bright. Edmonton also fairly bright. It's a little misleading. There was a bit of snow on the ground when this image was taken in both of those cities. So the pollution, the light pollution upward light was a little bit accentuated compared to the other cities. But we do know that both of Edmonton and Calgary are much more brightly lit cities than the big cities along the coast. So here's the light that's directly upwards. Now, we've been talking about sky glow, and so what we have to do then is scatter this light amongst the dust particles and the air molecules and so on. And so then the areas where we can see the impairment of the faint stars is basically this. And now what we can see is that the corridor from Calgary through Red Deer up to Edmonton is pretty obscured. So there isn't a lot of visible stars through parts of that. And that's, unfortunate. A north-south pathway is exactly what a small bird might be using to do its fall or spring migration. Another important migration pathway is over here, up from Washington State, up the Okanagan Valley here. That's actually Kelowna right there, and Vernon and so on. And this, we know, is a major bird migration pathway, and it's actually a pathway my sister, an ornithologist, is working in right now. She does bird banding and other studies in this area. So what we have are two areas here, this one in British Columbia and Washington, and this one in Alberta, where we have migratory pathways that are impairments of the faint star visibility. And this has consequences for those birds that choose to navigate by the stars. little bit closer to the ground. This is not such an issue in Canada, but it's a worldwide issue anywhere where sea turtles nest. The young sea turtles, and here's a photograph showing a little group of them here, individual little sea turtles, working their way towards the shoreline. And what's attracting them towards the water is a reflection from the moon here on the water. So that's what they're keying in on. Now you can easily imagine how things can go awry when you might have street lighting on properties adjacent to the beach, and then the sea turtles actually, the hatchlings, then head over towards the roadways instead of towards the water. And so we have much more predation, and of course all the hazards attendant with small animals on roadways. Back to birds, we actually have this problem here in Canada. This is a puffin, and newly-fledged puffins, known as pufflings, will fly towards artificial lights along roadways instead of off to the sea, which is what the nature intended. They, again, are looking for that glint of light off the water, and typically they're looking for moonlight. But if there's artificial roadway lighting, they will get lost and head to the wrong direction. This is a broad-based issue for lots of intermediate to small seabirds, any of which use a very similar strategy for their life, and that is that these smaller birds, which go out to hunt for fish and krill and so on, return to land at dusk or at night in order to avoid the predators. So this is an East Coast bird. The related birds on the West Coast are things like the ancient cassins and marbled murrelets, for example, all of which are dawn or dusk flyers or night flyers. And they too have been seen getting disoriented by lighting, typically around fishing trawlers. And more broadly, we see shearwaters in the more tropical climes. A small bird, unrelated to these, but a very similar habitat in that it's a small bird trying to avoid predators. It too is a dusk and dawn flyer. And so what we have is a particular niche being filled by different species around the world, all of which are prone to the same issue of being disoriented by light, particularly light near water. Now, birds can be disoriented whether they're seabirds or not by light. And for example, in Toronto, over 1 million birds are killed by colliding with buildings each year. An organization I would highly recommend you check out is FLAP.org, and that's Fatal Light Awareness Program. It's a Toronto-based organization, but they have programs that span the country, and there are cities in the U.S. as well that are looking at what's going on with these birds in cities. So what is going on with these birds in cities? Well, it turns out that warblers, many of who live in forests, which might look a little bit like that image on the left-hand side, choose to fly into the light areas between the branches. And it's possible what's confusing them about the downtown areas of these cities is that they are choosing to fly into the lit areas in these buildings. You can easily imagine that the safe haven of flying between branches can be easily translated in a bird's brain into flying into the lit areas between the dark areas. And unfortunately, that means they're colliding with buildings. And that's really where we're seeing these major bird kills, particularly during migration seasons. The other problem they have is that they don't want to fly out of a lit area into the dark. And quite often they'll end up flapping around in lit areas until they drop to the ground from exhaustion. And this was a problem in New York. This is the Twin Towers tribute lighting. And all those little white specks you see in that image are actually birds caught flying around in the beams. Nowadays, there are spotters that tell the people running the spotlights when to shut down when they're catching too many birds into these beams of light and they don't want to exhaust the birds. And so they turn off the lights until the birds disperse, and then they can go back on. Unfortunately, as you know, the September 11 event is basically in the middle of the prime time for the fall bird migration. So we see lots of warblers and other songbirds in this situation. All right, let's get away from birds for a little bit. We've got Daphnia, the sea, the water flea, sorry. It migrates with light levels in the water column. And what happens is at night, they come up to the surface and feed on the algae. And in the daytime, they drop down to stay hidden. Now, in situations with light pollution, the water flea tends to stay down, so they don't get up into the shallow water at night to eat all that algae. And that algae can then continue to bloom and overwhelm the ecology of the pond. And so you end up with algal blooms, and which lead to poor water quality, basically oxygen starvation. So light pollution has a very profound effect on water bodies. An example here from Alberta and Saskatchewan of an animal that is impacted by the light at night, artificial light at night, something called Ord's kangaroo rat. And I'm going to talk about the behavioral effect here again of the light. Everything we've talked about so far has been behavioral effects of light at night on animals. Although it looks like a very widespread population in western North America, down into Mexico, it turns out that these little animals, they're kind of a little jumping rodent, live in a very specific habitat, which is sandy dunes. And so what happens, even though this purple mass on this slide suggests that they're very widespread, in fact, what you have is a series of small islands or isolated populations of these kangaroo rats. And so that there's not a lot of exchange between areas because they need these sandy dune fields to live. And that means that the Canadian population is separated from the American one. Now, how does this little animal go about its life? Well, it's nocturnal. And it does that because of prey animals, mostly hawks and so on. So it gathers its nuts and seeds at night. And in Canada, we have a 90%, actually it's more like 95% winter die-off due to insufficient body fat. And the issue here is that this animal suspends its activity during full moon due to the brightness. And so it basically hunkers down until it gets a dark night. And therefore, it's really susceptible to light pollution. In the environment where these animals live, we're looking at maybe 30 or 40,000 oil and gas facilities, some of which are lit. And you can imagine if they're in the wrong situation, close to a favorite habitat for the Ord's kangaroo rat, that we can actually have significant impacts on the life and survival of these animals. Talk about behavior. If you're a frog looking for a free meal on a firefly, this is probably not what you wanted to find at the end of your little leap, Christmas light. And so, light at night can impact animals' behaviors in ways we sometimes can't even imagine. So just to sum up the behavioral effects of light pollution, we've got some birds having difficulty migrating using sky clues, whether it's stars or naturally polarized light, which I haven't talked about, basically caused by light pollution or artificial sky glow. We have large animals, which we have not talked about, that avoid lit areas, and this is like bobcats, lynx, cougars, wolverines. You can pretty much cut the foraging area for a large carnivore in half by putting a roadway in with lighting. The animals tend to shun the lit areas, so now it's almost like you've put up a fence merely by putting up roadway lighting. Small animals will avoid an area due to the chance of predation. And so we've got bats and some of the smaller nocturnal shorebirds, some of which we talked about, and waterfowl are in that. Of course, the kangaroo rat is in there. And also the nocturnal predation in general. Even if the animal cannot avoid the area, their rate of being eaten is much greater just because of the artificial lighting. So we've got the behavioral effects out of the way. Now I'm going to touch on hormonal effects, and this applies to humans as well as animals, but we're going to basically focus on humans here for the most part. So most environments on Earth, except for the extreme polar regions, have this 24-hour day-night cycle. And all life has basically evolved with this diurnal variation built in. So we have a 24-hour clock. And essentially, animals or organisms as diverse as bacteria, algae, insects, and humans have a molecular clock known as the circadian rhythm. And it runs on approximately a 24-hour cycle. And the timekeeper is this molecule here, melatonin. It's produced at night, and it basically has many biological effects through the activation of melatonin receptors. It has a number of other important roles besides controlling some of the hormonal systems, and that is it has a powerful antioxidant effect, particularly for protection of nuclear mitochondrial DNA. So this has postulated anti-cancer impacts. How light controls melatonin? Well, this is where the light pollution meets circadian rhythms. And in higher animals, if you subscribe to the higher and lower animals theme, in birds and mammals, the primary photoreceptors are in the eye. So if we get light at night shining in our eyes, we are able to trigger certain effects. In other animals, such as frogs, yes, the melatonin receptors, the receptors that control the melatonin levels, are in eyes, but they're also in the skin. So any part of the animal that is exposed to light at night can be impacted. And so the eye for humans is a fairly complex device, if you will. During the daytime, we rely on this here, a set of 3 different cone cells whose broad envelope of sensitivity is something like this. There are slight variations between the 3 that allow us to have color vision, but the primary sensitivity is in kind of the middle range of the greens through the reds here. At night, we have our black and white vision provided by the rod cells, so scotopic, so going from photopic in the day to scotopic, and the brightness sensitivity is offset from the visual, color visual sensitivity, but we see then primarily kind of in the greenish part of the spectrum is where we have the most sensitivity for this set of cells. Now these cells don't give us the high visual acuity images, but they are sensitive to much lower levels of light. And so we rely on this to give us our kind of our grayscale night vision. And fairly recently, in say the last 15 years or so, there's another set of cells, the intrinsically photosensitive retinal ganglion cells, quite often abbreviated as IPRGCs, have been found to have this sensitivity, and it's these cells here with this sensitivity over in the blue end of the spectrum that control the circadian rhythm. And I had mentioned that the circadian rhythm is about 24 hours. It turns out it's reset every time we have light. And basically the cycle free runs a little bit longer than 24 hours, but every morning we kind of reset that with this blue light in the pre-dawn. And so that way the circadian rhythm matches our actual daytime and nighttime cycle because of this resetting. And I don't think it's an accident light uses blue light to regulate cycles. When you think about water, you think about kind of a bluish color to it. And that's because it's absorbing more of the red end of the spectrum than in the blue end. So if you look at the spectrum here, it's got a high ability to absorb the red colors, less and less ability to absorb colors over and towards the violet end down here. And what this means that when we throw the solar spectrum onto this is that the amount of light that penetrates at depth changes its peak or its color, such that in shallow water you might be able to see the red light, but by the time you're in deep water, we only have the blue end of the spectrum here. And so the reality is then is that this part of the spectrum that makes it down to here is basically the similar wavelengths that the IP RGC cells and their equivalents in or the equivalent chemicals in bacteria or algae are all basically in this part of the spectrum. And so this is how life learned to match their biological cycles with the rotation of the Earth that gives us our 24-hour day-night cycle. Well, what does that mean for us? What's in it for me, right? Here's an example of melatonin levels. Just kind of a bunch of graphs here, but we'll start off here with melatonin. Low levels during the day, and at night it starts to pick up. And this assumes that there's no light pollution, because melatonin production is suppressed at night if you have light on. And so we end up with this cycle that has peaks of melatonin levels at night, and that regulates a bunch of other compounds. And so what happens, for example, we've got cortisol actually builds up over the course of the night, and then we basically break it down during the course of the day. Now, cortisol is a stress hormone, and basically what happens is as it builds up, it allows the body to heal itself, so that the ravages of the day are then kind of taken back and re-healed over the course of the night and in the early morning, and then we break down the cortisol levels again over the course of the day, and then repeat for the next night to build it up again. Here's one, growth hormone. And so growth hormone spikes early on in the night and then drops off. So you can imagine that if you're suppressing your melatonin levels, you might switch and change the patterns of both the cortisol and your growth hormone, and that can have unknown consequences. We have also on the other side here a variety of agents within the blood system that are help the blood system basically fight infections and so on. So we've got our lymphocytes, our white blood cells, various other parts of the blood system. And what we see is that, again, there's a switch between the daytime and the nighttime as to which ones are active or not active. The body is very much like a symphony, and what we have here is the conductor, melatonin, making sure that all of these compounds operate at the appropriate time so that they do not interfere with each other in the healthy life that we hope to live. Now, there are other little, more mundane things. This one caught my eye, urine production. Basically, what happens at night, the melatonin tells the body, produce a little less urine, please. We need to get some good sleep here. And it allows the urine then basically to be a daytime event for most of us. Of course, if you're getting older like I am, you might notice that this graph is probably more like a flat line nowadays. Ooh, too much information. All right, so we've got quite a lot of material here. So we first looked at the behavioral aspects. Now we're looking at kind of the hormonal or health aspects of nighttime lighting. And so the nighttime lighting, particularly blue light, disrupts the production of melatonin. That regulates the circadian rhythm. Circadian rhythm controls all those key hormones, things like follicle stimulating hormones and estrogen and a few others, which control things like puberty, can be messed up with light pollution. And these have consequences for us in terms of sexual maturity and also for things like cancers, especially with the estrogen being a strong mediator of certain types of cancers We have breast cancer in women and men, elevated risk if you've got a lot of light on at night. All right, moving on. We'll go back to Dr. Phil, who's going to talk to us briefly about the some of the new technologies that the engineers we know better.
Okay, so we're getting short of time, so I'll try to be brief here. But I think we're all familiar with the figure on the left showing the classic orangey glow of the sky due to the use of high pressure sodium lights. What can you say? Very good at illuminating the situation at night, but gosh, there's lots of opportunity for glare, and certainly sky glow is a consideration. And in recent times, the concern about these guys is their huge consumption of energy relative to what the LED light can do. So many places. I'm sure I live in a part of Calgary where they're switching out the lights right now, and it's kind of a shock to the system when they change these things out. Part of it is that the LED lights are incredibly bright, and the amount of glare that they provide is really amazing. The first time I drove in a new part of town where the lights had been swapped out, I actually, in the middle of the night, I had to put my sun visor down because they were so bright when I drove underneath them. I thought there was the sun in the sky, and it was actually very uncomfortable to my eyes. And I put my sun visor down. So what's happening with these guys is fundamentally, if you just look at the spectrum of the lights really quickly. So the smooth curves here are the same three curves that Roland was pointing out with response to the eye, what your eye does during the daytime, what it does during the nighttime, and the cells in your eye that control your melatonin production. This thick, bolder curve is the spectrum of the typical LED light. The way they work is they produce inherently a huge spike in the blue, and then some phosphors inside of the lighting bulb that convert the ultraviolet light and the blue light to a more continuous spectrum over in the visible part of the spectrum. So it's the blue light that messes everything up. This is the light that your eye responds to, and is supposed to be turning off production of melatonin during the night. But with the way that these light bulbs work, they produce this huge amount of over emission in the blue. So, and another thing that Roland hasn't mentioned yet is your eye as an optical instrument. A blue light is focused differently through your eye than red light. Very stark example of this is in downtown Calgary. There's some buildings with some logos up on the top of the building in blue light, and they're strange to look at because they look out of focus all the time. They're not, of course. They're perfectly constructed, but to the human eye, because they're illuminated in the very blue part of the spectrum, they look out of focus. The human eye just can't focus light very well. Also, your pupil, it responds primarily to blue light. So it's very strange to put up new lights in the city that are very, very blue, because that constricts your pupils, and that prevents the light from going into your eye. So they're producing all of this low energy consumption light, but they have to throw more of it down on the ground because your eye is actually cutting out more of the light because your pupils are constricting. Also, the light is blue, and you can focus blue light very well. And of course, there's lots of problems with debates about what's going on with the overuse of these bright blue lights and the overall amount of sky glow. The lights themselves, they're nicely cut off. They don't really inherently throw a lot of light up into the sky, but because they're so bright, they shine a lot of light down onto the ground, and that reflects back up into the sky. So are we really making an improvement from the sky glow situation in the overall case? I think the preliminary studies are showing that sky glow is actually getting worse with the use of LED lights. So that's all I wanted to say in there. Anything, Roland, if you wanted to?
No, I think we're pretty much at the end. We just got a little advert here for the Royal Astronomical Society of Canada. We have quite an active committee and quite a few members across the country who are active at this light pollution abatement. And we look at the light pollution across the country, and we try to advise federal, provincial, and municipal governments and agencies, along with businesses, to take action, reduce unnecessary glare, uplight, and light trespass. And we're certainly bringing to their attention this aspect of the cool white, or so-called cool white LEDs with their very strong blue output. We have, as a society, a program for recognizing areas that have dark skies and access for astronomical observations. We have dark sky preserves, areas away from city lights, and they have, we require nearly pristine skies or pristine skies within them. Urban star parks for more light polluted areas. And we had recently, in fact, we're about a mile away from Canada's first nocturnal preserve at the Anne and Sandy Cross Conservation Area, where we're broadcasting from right here. The nocturnal preserve is an area where basically the lighting at night is regulated strictly for the preservation of the natural night environment. There's no regard for astronomical use, and quite often sites like this don't have access for astronomy, whereas our first two categories, the Dark Sky Preserve and the Urban Star Park, were more for preserving the night sky for astronomy usage. And for all of these categories, the on-site lighting must be full cut off or directed downwards. In fact, only a small area of the park, lighting curfews, i.e. you turn off the lights at 10 o'clock or whatever, that's encouraged. We also have constraints that the non-reserve areas outside must not invade with their light onto the park area. And so that's an important aspect of each of these dark sky preserves or star parks or nocturnal preserves must consult with their neighboring properties to help them understand what it is that we're striving for. An example of a good little cut-off light on the building. And this map's quite busy, but it's a good busy, I think. These are all the dark sky preserves, urban star parks, and nocturnal preserves recognized right now by the Royal Astronomical Society. The base map was one produced a few years ago from, by Canadian Geographic magazine when they were talking about dark sky preserves, and I decided I was going to update it with a bunch of all the new ones in here, and really it's starting to look quite crowded, and I'm very pleased with that. Canadians have embraced the preservation of the natural night from coast to coast, and so we are looking favorably at maybe being able to protect quite a lot of our night sky. So we've got more programs underway. We've got two projects in Alberta underway right now, another nocturnal preserve, as well as a dark sky preserve. And actually, the dark sky preserve is an interesting one in that it's a joint project between Waterton Lakes National Park and Glacier National Park in the U.S. So this will be the first cross-border one that we've worked on. The International Dark Sky Association has quite a few dark sky places and parks and reserves across the planet. This is the first one where we're basically working hand in glove with each other to make a first cross-border one. All right, we're at the end almost. Final exam time. Light pollution misconceptions. Let's go. So which of the following are misconceptions about light pollution? So here's your first choice. Light at night prevents crime. More light improves visibility. You can get good illumination by throwing light a great distance. Light pollution is not really pollution because it goes away if you turn off the lights. Or E, light pollution is only a problem for astronomers. Or are all of those misconceptions? And the answer is truly F, all of the above. Give it a think. If you guessed F, you were correct. All of those are misconceptions about light pollution. Let's look at them in turn quickly here. Light at night prevents crime. Best studies on nighttime crime show that illumination increases crime rates, primarily by moving it from the daytime hours into the nighttime hours. B, more light improves visibility. Well, while some light can improve visibility, too much can create glare, which always reduces visibility. C, you can get good illumination by throwing light a great distance. No, not really. What you're trying to do by, for example, aiming a light out too far, is you end up creating glare and trespass, because this kind of lighting in this angle is never very good effective illumination. And it's really this illumination that's more directly pointed towards the ground that is useful light. So by the time you get out to here, you're looking at glare and trespass. Oh, answer D was light pollution is not really pollution because it goes away if you turn off the lights. Well, light at night disrupts the natural rhythms of hormones in people and animals, and even if the light is on only for a short time. So the effect of light pollution does not go away when you turn off the lights. And light pollution is only a problem for astronomers? Well, no, right? Increased crime, impaired visibility, light trespass, and impaired health are all caused by light pollution. And these affect everybody. All right, couple of slides here with some more information. Starting off with Dr. Phil's favorite organization. Go ahead. Oh, he's letting me speak. All right, so the University of Calgary's Rothney Astrophysical Observatory has a dark skies page, which you can see there. The International Dark Sky Association has very extensive resources and also a very useful Twitter account. For those of you who are bilingual or want to look for French language material, the Mont Mégantic International Dark Sky Reserve is a really good site for that. I'm going to pause a little bit if you're taking notes. We can always go back.
And I would just add that if you wanted to have a look at that animated GIF I showed earlier, if you go to the homepage of the ARIO website, there's a little link to it just on the bottom right-hand side.
And then, of course, the Royal Astronomical Society of Canada has the national page has the light pollution abatement site. The Calgary Centre of the Royal Astronomical Society of Canada also has a fairly extensive light pollution abatement site. And finally, there is the Twitter account at RASC_light pollution abatement LPA. That's basically an account I run. Hopefully people find that of some use there. And I see a little note there. Julie says you can click the link directly. Want me to go back on the last page so people can open up their windows on the various there, Julie?
Hi, yes, yeah, I'm back. Thank you. I'm sorry, my computer kind of crashed, but I managed to come back with you guys. You can hear me, right?
Yes, we can. All right, so
Okay. Yes,
so people can click on these direct. Oh, yes, they are live. Ooh.
yes, you can click on the links directly. And maybe I'll find a way to include them in the email I'll send anyway to everyone. So first of all, thank you very much to both of you. This has been very informative, lots of information. And hold on, I'm just coming back with all of you here. There we go. It's getting dark here. And so if people have questions while we're just talking a little bit here, please take the time to type in the chat. That's what it's for. But there was a lot of information from both Roland and Phil. And so thank you very much to both of you. Yeah, your camera is doing something weird when I'm here, so we just see part of Phil's face right now. Okay, there we go. That's better. So there's a lot of information. This is actually the first time we have two speakers at once, and it's kind of interesting to see their interactions between two of them. There's a good question from Gavin. Excellent presentation, but how do we convince the politicians? Which one of you wants to take this one?
I'm going to defer to Roland.
We both have presented two politicians, and I have to say, the Dr. Phil wowed them with some of the the night sky imagery from the Rothney Astrophysical Observatory, I spent more time talking about, you know, the crime and the health aspects. And I'm not sure which one works better. I'm always worried that if you talk to politicians about astronomy, they'll look at you as a special interest group and maybe will discount your arguments. So our emphasis in Calgary over the last 20 plus years has been talking about the environment and the cost of light pollution, both from the just the straight up energy cost, and also perhaps where you've got the risk of accidents due to bad lighting. So we've tended to go that way, but when we presented to the City of Calgary City Council, Dr. Phil's astronomy presentation was the one that wowed them because of the great snazzy graphics. And we all know that, you know, there are many people in the world who are not amateur astronomers, but will visit Astrophoto of the Day, APOD, every day because they just love the imagery. So I suppose the best way to do this is some mix of the two sides of the story. Does that help?
That's very interesting indeed. I see someone's typing. So again, we went over the hours, so some people have left. And if you do have questions or comments, please type them right now, as I think we'll wrap up very quickly. Oh, I like that. Illuminating presentation. So while you people are typing, I want to thank again our guest speakers who took the time to prepare this and present to both of you, to all of you, both of them from Calgary right now.
So I see Gavin's question. Yeah, we've got that issue, don't we, in Vancouver, where we do have a population that seems to be far ahead of the politicians. And that's an interesting enigma. I think what you have to do, and unfortunately we could only touch on the issues of the LED lighting, because there's a whole field there that I could talk about and Dr. Phil could talk about in terms of what really is effective green, if you will, lighting for roadways. And I think that's yeah, you're up against a very significant group with the lighting engineers who like to see the cool white lighting, because it is very efficient to have more of that blue, because it's easy to make that blue. You lose efficiency if you're trying to convert some of that blue with the phosphors over into the longer wavelengths. And so there is this pressure to sell the politicians on the bluest light possible. I'm not sure how we can deal with the specific example in Vancouver there, Gavin. That is a one I've been pondering myself. Sometimes you do need an inside person. We were lucky in Calgary that the councillor who proposed the lighting in Calgary was actually a lighting engineer and a former IDA member. So he knew all the strings to pull, both on the outside and on the inside.
That's very interesting. Okay, hold on, I'm coming back. I try to hide every time you talk, because otherwise we have a weird view of your screen. Okay, well, I think that will wrap it up. And thanks to everyone who's still watching, and thanks to everyone who's watched the recording this far. And again, thank you very much to Roland and Phil for your time and for sharing your expertise, as Linda put it in her comment.
Bye.
Oh yeah, there we go. Bye-bye.